So once again, my name is McClarty. I'm president of phoenixNAP. Today, I will be presenting the differences between deploying bare metal Kubernetes on bare metal versus public cloud. A couple of housekeeping items. So first, there is a Lego Star Wars kit that we will be giving away roughly now after the presentations today. So please feel free to scan the QR code. There will also be links available afterwards to anybody that's interested in participating. With this, I'm going to take an opportunity here to talk a little bit about our organization. So we're what's called a pure infrastructure as a service organization. We have been in the infrastructure services game for over 12 years, and we continue to deploy and develop new ways to deliver services that are pure IaaS. One of the latest offerings that we have is called Bare Metal Cloud. Let's step back a little bit and look at how Gartner sees the cloud native ecosystem today. So this is the latest from Gartner. This recent article information, and one thing that is very clear to the market is that containers are becoming a core technology. Not just Kubernetes, but containers in general are a big part of change right now for organizations. Cloud native principles, and again, not just Kubernetes. It depends on who you ask. If you ask Gartner, they see a more generic version of this. If you talk to the Cloud Native Foundation, they see a very specific direction of Kubernetes at the heart of the technology cloud native transformation stack and everything around that ecosystem. And so we're going to be taking it from a perspective that is more general right now, and then we'll go more into the actual Kubernetes principles themselves. But cloud native adoption of principles is continuing to accelerate and grow. Cultures, from small to the biggest, are becoming very developer centric. Developers are in very high demand right now. The way that software as a service and also platforms and applications right now are being delivered is changing. Everything has become an API world at this point, and that this move is not going to stop. It's going to continue. So organizations are trying to also create better ways to interact with each other from an API perspective. And so the traditional middleware, what used to be called middleware, is really expanding, and it's really becoming more agnostic on platforms. And so there's better hooks that have to be created between organizations. So today, Kubernetes, again, how do we see it being used? So from a general market perspective, there's more adoption happening right now. Some flavor of Kubernetes is being adopted today. More is being moved into Kubernetes workloads. About 74% is now using some flavor of Kubernetes in production. Now that could mean to a very large organization that their next generation product might be a very Kubernetes centric focused product, or it could be that their backend is completely rewritten and it's going to be done from a Kubernetes stack perspective. But there's a very production, high availability concern right now going on. And most containers today are in a hybrid environment. What that means is that there's a portion that is public cloud, the hyperscaler type business, and there's a portion that is what typically is called on-prem or some variation of on-prem. So on-prem can also be defined as colocation services. It can be defined as services that are interconnected with hybrid cloud that are somewhere in the middle. But a portion of it is run in public cloud, and a portion is run at the home data center or the colocation facilities. And as you can see, 28% are true public cloud right now. So there's definitely a lot of different ways to deploy Kubernetes technologies. So from a challenge perspective, what are some of the things that we're seeing right now for between on-prem and public cloud? And again, on-prem has a wider definition of not just being physically to you, but look at it more from like not being in public cloud. Storage is a big concern right now in public cloud. And the reason for that is because a lot of times the latency of the network becomes an issue. Also, the how the storage is delivered becomes an issue. And Kubernetes, you need very fast storage. You need a good stateful environment. You need good ways to save your your states. So storage is a major concern, especially in Kubernetes deployment stacks. Complexity is also big. Public cloud is slightly more complex in many ways. It's very easy to get into, but as you scale it out in your work, you have more components, more pieces that have to be glued together and work together. And so the complexity driver and the adoption rate becomes, as you scale up, is bigger. And security is always a concern. I mean, it doesn't matter whether you're on-prem or public cloud. Security is always a major concern for organizations. Those are the top three, but there's also like some differences here. So in general, public cloud does offer better monitoring, better telemetry, better logging systems. If you look at on-prem, the amount of telemetry you can get from your actual systems is significantly better than that. So from a top three perspective, storage, complexity, and security are always going to be a public cloud concern. So really high level here, not specifically how we do it, but how it's being done in the market. We do have a bare metal cloud product, and so I'm going to abstract this from a very general perspective on purpose. Today, bare metal cloud is from a comparison perspective, we just look at very basic container stack, a container engine that could be Kubernetes. There's always a guest operating system of some sort. Bare metal gives you the most direct access to that container engine, to that Kubernetes cluster. The orchestration layer is actually being done for the communication of the bare metal systems themselves, is being done at a layer outside of that. There's typically an ephemeral orchestration layer that is there for networking, that is there for turning up the servers, turning them down. That's typically where the intellectual property goes for most organizations. The bare metal systems themselves and on down to the Kubernetes stack is pure. So there isn't the overhead typically that you find in public cloud, because public cloud where it's doing a lot of its orchestration is actually at the VM layer. So that green layer right there, that's where a lot of the orchestration, a lot of the overhead, and some of the challenges with that is that it's very difficult to troubleshoot. When something does go down and you have another layer of orchestration along with a layer of Kubernetes that are right next to each other, the actual troubleshooting, it becomes a very difficult inside the public cloud ecosystems. So from a high level, some of the strengths of bare metal cloud itself are performance. You have a speed and you have hardware transparency. And because of these three factors, you get to decide. You have a lot of control over what actually goes in, and you can really dictate how you scale out. Plus, because of the general nature of it, you have no vendor lock-in. Now, on the other side of the house, some of the things that you do have to have is more hardware experience. So unlike public cloud, where you have t-shirt sizes to start out with, small, medium, and large, that concept does exist in our bare metal cloud. But you get the true value of it when you understand more, the component side of the house. What am I getting from a speeds and feeds perspective? What are the things where I can optimize? That's where really you get some of the newer concepts I talk about here, as it can be seen as a con, because you do have to have a little bit more knowledge of the actual hardware itself, and it's right now it's best for production workloads. So that I'll put that as a con, not because it's bad that you're in production workloads on it, but because unlike public cloud, where it's very easy to start, it's easy to get to, it's easy to scale, but it's complex to scale. So that's the difference there. I mean, it's very easy to keep on growing inside public cloud, but the complexity nature continues to increase as you scale out. It's not necessarily the best thing for a startup organization. It's better for a company that already has been there, done that, understands what the workload is, has some of the profiling, wants to basically look at it from a comparison basis of how they can optimize and how they can make their application faster. And that's where public cloud becomes very expensive, and that's where you get a lot of the performance hits. That's where the vendor lock-in starts to occur. That's where it gets very hard to scale out and complex to scale and costly to scale inside. So you do have a lot of costs there that are associated in public cloud, and that's in general public cloud. That's not just one provider, but they're easy to get into, difficult to scale out in. Whereas bare metal cloud is maybe a little bit more difficult to get into, but from a scale perspective, much more powerful. We cover some of these key points. Again, there's always a TCO conversation that comes in, and I'm not trying to make it a financial conversation, but past that, we have some nice things about bare metal cloud. For example, one of the things that I'm not making very clear is that it's dedicated infrastructure. It's dedicated to one organization. So it is your control. It is your stack of services. You're not sitting in a shared environment with others. You are in a dedicated environment with your own dedicated processing horsepower. And so that eliminates a lot of the problems that come along with multi-tenant environments, like noisy neighbors. You do have very, you can get into a high performance and also really fine tune your application and really get into even like kernel, for example. I mean, you have full control of the entire environment. So this is not a virtualized environment; it's a physical environment where Kubernetes plays very nicely as well, because you can optimize Kubernetes stacks as well on top of that. The options are I would say are more powerful also when it comes to how you integrate with bare metal and as a platform when it comes to containers. Today, for example, we have vanilla flavors of Kubernetes that we support, and we also have virtual flavors of that as well that sit on top of bare metal cloud. So most container operators today we integrate with. We did a lot of work on the CD side of the house, on the orchestration side. Again, a little bit more about bare metal, just our bare metal cloud. So this is where it's more specific to us. We have quite a bit of integration work that I mentioned on the continuous on the CD pipeline, continuous delivery side of the house is really what we focused a lot of efforts. So integration with third-party platforms like orchestration platforms like Ansible or Pulumi, Terraform. We also SaltStack, Chef, Puppet, your more standard deployment technologies. We integrated with right away, right when the product has started. That's the first thing we did, and then we also knew that others would want to write their own code stack. So we developed multiple SDK flavors, and they're on GitHub. We've released a lot of code as well. We believe in the open source movement, so we've been actively releasing code stacks. Again, you get dedicated resources. You have the same flexibility that you have within public cloud, as well as hourly and reserved instances. And your deployments are quick. I mean, we're talking about a dedicated infrastructure stack in less than 60 seconds. Especially if you select standard Linux operating systems, it's extremely quick to get up and running. Today, we're globally available in the US, Europe, and Asia. We do support the latest generation Intel platforms that are Xeon based. We also have SGX availabilities, which is important. And again, maybe some of these terms may not have relevancy, but if you are a focused organization around security services, SGX gives you a lot of functionality, and that's from a chipset exposure perspective. And that's some of the learning curve I was talking about. We integrate with Rancher today, so we have multiple flavors of Kubernetes support. We have vanilla Kubernetes. We also have a flavor of Kubernetes that is based on Rancher. I'm going to show you how easy that is to deploy. We also give you bandwidth for free because we believe that bandwidth should not be a major cost basis for you from a decision perspective, especially as you scale out. I mentioned storage was a major concern when it comes to the public cloud. This is why we have multiple flavors of storage, including S3 compatible storage, but we also have very fast NVMe flash storage and more storage availability options coming in the near future. And we also have a really strong GitHub repository that I mentioned before, and API library and CLI as well. We always develop around the API first, so we make sure that exposure is available to you as a developer. CLI is also available, and then UI last. So we always focus on making sure the API exposure is the first thing we do. And then we do currently support us as well to the more enterprise focused people that we do have VMware integration support today, and that is expanding as well. So let me show you this real quick. We have integration with SUSE Rancher that I mentioned, and that's what I'm going to be going over a little bit more, and how easy it is to launch. We have native Kubernetes controllers as well, and there's plenty of articles that we've written around how to integrate. If you want to go more vanilla Kubernetes, if you want to really get in and really learn Kubernetes and deploy the stack, we have a lot of supporting documentation around how to do it, and then with examples and code snippets. And we continue to expand our support of Kubernetes controller. And then the SUSE Rancher integration, it is very UI easy, but we have also exposed everything by API. And so here I'm going to show you real quick. So this is our bare metal page here. I'm going to log in real quick. I already have a login set up, and we do have, as I mentioned, the capability of multiple regions. We also have different billing models, and we also have the ability to be able to do instance types based on single CPU or dual processors as well. And the way we do it is we do follow a t-shirt model, but then we tell you exactly what you're getting behind it. That you will not see in public cloud. It's very difficult to know what generation of processor you're getting. which makes it more difficult, I would say, from a performance perspective, to also program against that. Because if you're getting a cluster of systems and they're all over the world, and some are on generation V, say generation 1 processors versus generation 3 processors. Now, what typically most companies are doing is they're developing against the lower end processor, and so they're losing performance, or they don't have the same performance based on region, which does become a problem from an architectural perspective. And so, knowing what you're getting and being able to plan around that, and to be able to get the resource optimization is very important from an application delivery perspective. We have made it very easy to actually launch Kubernetes stacks within our system. Like I mentioned, I'm going to show you a little bit here before I start that. We actually have very well documented APIs. There is one for the Rancher Solution API that is actually is readily available, and that's on developers.phoenixNAP.com. And also we have, like I mentioned, our Kubernetes controller that is also open source, and that's on our GitHub page under github.com phoenixNAP. So from here, all we need to do is create a couple buttons here. We select our region, select the number of nodes that we want to deploy, so we can do 1 or 3, and that's for high availability. So if you want to do like a very simple, just test the waters type node, you can just launch a one server node. But really, what's recommended is a 3 server node, because you get HA, and so that's really more for production workload. So once you select your node count, then you select what type of systems you want to deploy. And again, on the cluster side, they're all going to be about the same. So that way, there's parity amongst them. And so we'll just choose a simple one, and then you can launch and create a Kubernetes cluster, and click that button, and you will have a Kubernetes cluster with credentials within 5 minutes. Now, if I want to go into more advanced features, I can also do that. And so some of the options that we give you beforehand, you can also do this post as well. You're not limited. You can also do this post. So just type in a cluster name. So test.dev.phoenixNAP.com. I can also upload my SSH keys. I already have SSH keys uploaded to this environment, so that we can easily log into the system when my credentials are delivered to me. I can do simple things like I can upload my certificates. I can also take my nodes. Maybe the specific reason why I don't want my primary node cluster to be active. This one worker node maybe, or this node I want it to be in a certain state when I launch. You can also create a quick snapshot as well. And this is also where we're making a lot of investments is in more backup and recovery options when it comes to Kubernetes deployments, because that is a major pain point. People do need to roll back. Sometimes accidents do happen, or they're running their environment. They need to go to a different state or a comparison state for troubleshooting purposes. And so we are working on ways to make that easier. And then you click on create cluster, and you get credentials within 5 minutes. So again, very easy to deploy, different flavors. You get all of the same benefits that you do in public cloud, but with more hardware transparency, and you still get the speed, the simple deployment stacks, but you also get the performance and speed behind it. So just go a couple of use cases on why bare metal cloud versus a public cloud. So production workloads, I mentioned over and over again. We see a lot of production workload coming into the bare metal cloud, and that's really for financial cost optimization, performance based on the application. They're just not having that vendor lock is a big push. Companies want diversity, and again, the stats show that everything is running in a more hybrid cloud environment right now. A little bit of everything everywhere. It works very well with public cloud as well. So it works in tandem. It's not. It doesn't. You can still leverage your resources. Like, say, I have an RDS database. I still want to leverage inside a public cloud interface. I can still leverage that. So you're not limited. Also, we're not saying put everything in one system, but you can really cost optimize it. And that's why production workloads really come to bare metal cloud. Kubernetes management we talked about quite a bit. I mean, so being able to manage Kubernetes flavors, being able to deploy easily. The troubleshooting makes it a lot easier as well because of the way it's structured. You don't have a layer on top of Kubernetes. You get to use basically all your standard CD tools that you're used to. As a matter of fact, from a knowledge perspective, to be able to interface and use, all you need to do is just be comfortable with your credentials. You get your API keys from us from the UI interface, or and basically use that instead for your scripting. So it makes it very easy to deploy the stacks. And again, we do have a focus on Kubernetes support that is vanilla. So if you don't want to use a managed type cluster inside Rancher, you can do it yourself as well, so that we don't limit you on how you launch your stacks. Multi-cloud deployments I mentioned a couple of times. It works in conjunction with your on-prem and your public cloud, so it's also nice from that perspective. And then one of the things that is nice about bare metal cloud is from a speeds and feeds perspective, because of the amount of bandwidth you get. It allows you to do some global bursting very easily, especially when it comes to anything performance or hungry, but also from a workload that is very intensive on the actual bandwidth side. It makes it a very affordable way to do this, and also a way to really cost optimize and actually get really good performance out of your application. And with that, I am going to leave it open for some Q&A. I do know that we do have also another Q&A session. So if you have any questions along the way, please feel free to reach out. My direct email is ian@phoenixNAP.com. That's IAN@phoenixNAP.com. And I want to thank you again for your time. And if you need information, we're available to help. Thank you.